Find 12 difference. Spot the difference. Oh, these few spots are the difference of this picture. Five difference kids activities. Wow, so many pictures to spot the difference. So, are you able to spot the difference? What are we going to learn today? Today we are going to learn about isomerism.
These are the learning outcomes for this video. We are going to focus on define isomerism, constitutional isomerism, and identify and construct constitutional isomerism, which are change isomer, positional isomer, and functional group isomer. C, D, E, F, G, H will be discussed on next video. So isomerism, there are two. One is theoretic isomerism, another one is structural constitutional isomerism. So today we focus on this part, structural or constitutional isomerism, change, positional, and functional group isomerism.
What is isomerism? Existence of different compounds with the same molecular formula, but different structural formula. The molecular formula, for example, C4H9Cl, okay, it's the same, but the chlorine position might at position number at C1 or the position at C2. Okay, isomers, different compound that have same molecular formula, but again, different structure formula. So now we have to check one by one. Okay, different compound have the same molecular formula but different in the order of attachment of atom. Different order of attachment. Okay, so it can be change or skeletal isomer, positional isomer, and functional group isomer. So what is the difference between these three different structural isomers? First one, change or skeletal isomer. The isomer differs in the carbon skeleton. Different carbon change, but they have same functional group and same homologous series. Okay, madam want to emphasize, right? When we identify the isomer, we are going to differentiate between two structure. So in pair, okay, like just now, the spot the difference also with two diagram. Okay, let's check. C5H12. Okay, so 1, 2, 3, 4, 5. This is pentane, right? Okay, pentane. This one also 1, 2, 3, 4, 5. But the name of this structure is 2-methyl-butane. And then this one, 1, 2, 3, 4, 5. There are 5 carbon as well, C5H12. Okay, but this one is 2,2-dimethylpropane. Meaning that, okay, 3 of the structure have C5H12, but the change is different. This one straight chain with 5 carbon, this one straight chain with 4 carbon, this one straight chain with 3 carbon. But the molecular formula is still the same, C5H12. This we call it as change isomer.
The second structural isomer is positional isomer. The isomers differ in the position of the functional group or substituents in the same carbon change. Take note, this one is the difference in position for the functional group and substituents. Okay, we can try it. Okay, 1 chloropropane, 2 chloropropane, okay, with the molecular formula C3H7Cl. But we notice, right, this chlorine atom at position number 1, and then this chlorine atom at position number 2. Even though they have the same molecular formula, but the position of the functional group, this halogen atom, is different. For this one also the same. Carbon-carbon double bond is the functional group at the position C1 and C2. This one, carbon-carbon double bond as well, but the position is at C2, C3. They are having the same molecular formula C4H8. but the position of the functional group carbon-carbon double bond is different. The next example, C8H10. C8H10 is a side benzene ring, and then there are two substituents, CH3, CH3. If you check, the first structure is at position C1 and C2. That's why the name is 1,2-dimethylbenzene. For the second structure, position 1 and 3, 1,3-dimethylbenzene. And the third one is at position 1 and 4, 1,4-dimethylbenzene. So these three are the positional isomer, the substituent at different position. Okay, same for C6H14. It's a straight change. 1, 2, okay, 1, 2, 3, 4, 5. Okay, that's why it's 2-methyl pentane. This one is methyl pentane as well, but the position of the substituent is at position carbon C3. 1, 2, 3. That's why it's 3-methyl pentane. Okay, again, beside functional group substituent, the different position of the substituent also can be the positional isomer. Third structural isomerism is functional group isomerism. The isomer have different functional group and different homologous series with the same general formula. These are the different classes of compound that exhibit functional group isomerism. As we discussed before, change isomer or positional isomer, they are having the same functional group or same homologous series. But for functional group isomer, they are having different class of compound, but they are in pair. So for example, alcohol and ether, aldehyde and ketone, carboxylic acid and ester, alkene and cycloalkane, they are having the same general formula, but the functional group is different. For example, alcohol is hydroxyl, ether is alkoxy. Okay? So let's look at some example. C2H6O. Okay, so this is alcohol with the functional group hydroxy. And then this is COC, alkoxy. But they are having the same number of carbon, 1, 2, 1, 2, and then 6 hydrogen, and 1 oxygen atom. But the functional group is different. Same for this one. This one is aldehyde. Okay, but this is ketone. Both of them having the same molecular formula, C3H6O. And then this one, carboxylic acid. So, carboxyl. But this one is COC double bond O, carboalkoxy ester.
Practice 5. State. How many are isomer with the following molecule? And then identify the type of isomerism. Then draw the structural formula of the isomer. So there are 3 questions. Let's check the answer. But before check the answer, please try to do it by yourself first. Yeah, these are the answer for question A. With straight change 5 carbon, straight change 4 carbon, straight change 3 carbon. Quite similar with the example that we discussed just now. So among these 3, okay, we already draw the structural formula. So now we need to identify the type of isomer. So there are change isomer. As I mentioned just now, we need to answer in pair. That's why you must label. Okay, this is structure 1, this is structure 2, and then this is structure 3. And then compare. 1 and 2 both are change isomer. Then 1 and 3 change isomer. 2 and 3 change isomer. So you must compare one by one and then find a pair. So 1, 2, 1, 3, and 2, 3 all are change isomer. How about B? B, be careful, straight change 4 carbon. This one straight change 4 carbon. There is a functional group at position number 1, there is a functional group at position number 2. So what are the isomers between structure 1 and structure 2? I think you all should know, right? And then how about this one? This one, the position is still at carbon 1, but you check the change. The change is different. This one with change of 3 carbon. So you should know, right, what is the answer for these 3 isomers. So let's check. Yes, change isomer is between 1 and 3 because the functional group still at the same position, but the chain is changed. And then 1 and 2 are positional isomer because the position of chlorine atom is changed. Still is the same change, 4 carbon straight line, but the functional group at position number 1 for structure 1, and then the functional group for the structure 2 is at carbon 2. Okay, is there any answer? Please try and think. Okay, position must, if you want to check for the change isomer, right, make sure the position of the substituent or functional group is the same. Okay, and then for positional isomer, you must make sure the change is still the same, but the position of the functional group is different. So for example, this is C1, this one is C2. Next, question C. These four are the structural formula for C5H10O. Let's identify the type of isomer among these four structural formula. The first and the second with the functional group of carboxylic acid, but the change is different. This one is a straight change, this one with a branch. So you should know what are the relationship between structure 1 and structure 2. Structure 3 is, this is the functional group of ester. Okay. And then this one also the functional group of ester. So what is the functional group of ester? Carboalkoxy. Here. But this one start with C1, C2. Here start with C1. Okay. So this functional group is started from C1, and then this functional group is started at C2. So now let's check the type of isomer among these four structural formula. Okay, structure 1 and structure 2 are change isomer because they are having the same functional group, but just the change of the structure is different. Okay, so this is 1, 2, 3, 4, 5 pentanoic acid, and this one 4 butanoic acid. So 1, 2, 2 methyl butanoic acid. And then what is the relationship between 3 and 4? Positional isomer. Because they are having the same functional group, just the functional group at different positions. So this is start at carbon 1, but for carbon 1, but for this one start from carbon 2. So they are having the same functional group but different positions. So it's positional isomer. And then carboxylic acid, ester. There are different homologous series or different class of compound, but they are having the same molecular formula. That's why 1, 3, 1, 4, 2, 3, 2, 4, all are functional group isomer. Must always remember, functional group isomer is the structural formula with different homologous series or different class of compound but with the same molecular formula. That's all for this video. Next video is about stereoisomerism. Thanks for watching. Bye.